Right now, we will directly proceed to the keynote speech. To the panel discussion. So right now, I would like to welcome the moderator and panelists to be on stage. First of all, I would like to welcome the moderator, news anchor and program host in technology and finance and economics, Ms. Ashley Chu, to be on stage again. And also, I would like to welcome the panelists. Please welcome the Dean of the Industry Academia Innovation School of National Yangming Jiao Tong University, Jackson. Please be on stage to join us for the panel discussion. And also, I would like to welcome Zhiyuan Lu, the President of Macronics and Chairman of Ardentech. Ardentech, please be on stage. And also, I would like to welcome Yiwei Huang, Realtek spokesperson and Vice President of Strategy and Business Development. And I would like to welcome Zhipeng Li, the Head of Department of Engineering and Technologies of National Science and Technology Council. And right now, last but not least, we'll have one panelist joining us online, the Professor of the Department of Electrical Engineering and Graduate Institute of Photonics and Optoelectronics of National Taiwan University, Professor Zhi Wu, who will be joining us online right now. Professor Wu, are you with us? Okay, I think Professor Wu will join us later. Oh, okay, I can see Professor Wu right now. So now I will hand over the floor to the moderator, Ashley.
Thanks, Rebecca. And thanks to all our 5 speakers coming today to the panel discussion. Today we will discuss about the future of the semiconductor industry. I think that everyone cares about this issue. So let's go straight to the topic. We see that recently a lot of news around the semiconductor industry right now. In fact, the development of the global semiconductor industry is currently affected by various factors. In terms of the overall environment, there is the US and China conflict and the geopolitics. A lot of countries wanting to build their own wafer fabric plants like a new trend. And besides, we see that the United States has promoted the CHIPS Act, causing tremendous impacts to the semiconductor industry. Last but not least, whether Moore's law will continue is also in questions. Everyone tries hard to overcome the physical limitations, seeking breakthrough by 3D IC and advanced packaging. So what's the future of the semiconductor industry? I'd like to invite 5 speakers to share with us under these internal and external challenges. What are the top priorities for Taiwan's semiconductor industry to maintain its advantages? And how can we establish our industrial competitiveness in the next decade? So I would like to first ask Mr. Zhipeng Li, Head of Department of Engineering and Technology, National Science and Technology Council.
Okay, thanks for the moderator. In my opinion, in order to remain the leader of the semiconductor industry in the world, Taiwan must invest in R&D on critical technologies, search for new materials and testing methods, and cultivate outstanding talents in various fields, such as physics, chemistry, materials, and microelectronics, and the instrument technologies. In particular, we have to pay special attention to the emerging technologies for the next decade semiconductor industry. For example, 3D packaging, 2D materials, quantum computing, and silicon photonics, computing memory, and etc. In addition, because Taiwan leads in the semiconductor manufacturing, especially in the capability of advanced manufacturing and supply chain integrity, we believe Taiwan semiconductor industry should take the advantage of its superiority to develop vertical integration and cross-domain horizontal cooperation. In conclusion, as long as we can keep developing innovative technologies, cultivating outstanding talents, and improving the efficiency of the supply chain, we believe Taiwan semiconductor industry can keep in the leading role of the and to maintain the worldwide competitiveness. Thank you.
Thanks to Mr. Lei's opinion. And how about Vice President Yi Wei-Huan? What's your opinion to this issue?
Yeah, thank you. Well, first, I'd like to thank the invitation here. It's really an honor here to share with you my thought. To answer how we can maintain the success, I think it's very important first we ask, how did we get here? Now, what was the reason that, what have we done that we have success today? My observation, really, this is a multi-dimensional answer. Start with, many people will say, Taiwan, geographically, a very compact island, packed with very complete semiconductor infrastructure. Not only from manufacturing, from design to manufacturing, assembly, and test. We just heard that there's research institute like E3, and there's top-rated universities. They all pack in a very close vicinity, and all of us work very closely together, probably closer than most people will understand. So this is one of the first reasons I contend that this is very difficult to replicate in many other parts of the world. Okay, and another reason, my observation is, if you look at the products, the solutions come up by Taiwan companies, whether it's in design or manufacturing, oftentimes what you see, we are non-threatening. What do I mean by that? We are non-threatening. You look at the solution we have, usually we don't try to take a dominating position. For example, dominating a key platform or the most computational power. Oftentimes, we don't do that. And our solution, in many different ways, they complement with lots of leading technology. Our engineers, they have a very unique combination. What I mean by this, I always tell people semiconductor is a very strange industry. We heard about innovation. Yes, you need innovation. Actually, there's another element. Contrary to this, we need discipline. Semiconductor industry without discipline, you are not getting far. What I mean by that, in deep sub-micron design, there's not a lot of design margin you can have. Everything has to be very precise, especially when it comes to testing. Talk about boring job. Testing is a very boring job, but it's a necessary evil to make sure your pure product work. Taiwan, my observation, historically, we are heavily influenced not only by Western free-thinking, innovative mindset. On the other hand, we have the Eastern discipline and self-constraint, follow rules. It's a very strange combination. When you think about it, again, very difficult to find in other parts of the world. And because of the non-threatening this nature, what you see, oftentimes Taiwan companies are viewed as trusted player in many ways. And these are, hard-earned reputation. We need to continue to be that way. Last but not the least, I always say at the end of the day, we are high-tech industry, we need solution, we need engineer. We need solid engineering. I want to emphasize that at the end of the day, you need engineering more than scientists. Yes, it's very important you have the great innovation, but if you cannot reduce it to practice with high yield, with ease of manufacturing, you don't have the cost performance mindset, then it will be just a good dream. You wouldn't be able to reduce it to good engineering for the mass market. And that's what we need, so solid engineering. So with all the above, I contend to say, yeah, with geopolitics, with inflation, with lots of things, we cannot control. But what I just mentioned, whether you agree that is controllable or not, I contend that we have been doing that all the time. So if we keep doing what we are doing the best, I think, yeah, the future semiconductor is way far away from reaching the limit. We just heard that Moore's law is not a linear concept. Moore's law can be a 3D concept, and for that matter, higher than 3D concepts there. So all this with a good engineering work, with innovation and discipline, I really see this is the place we are going to see far more good news from here. Thank you.
Thanks to Vice President Huang. Yes, we are not threatening, and we are really working hard. Maybe that's what are that are our advantages, and that's why Taiwan has reached the top position in the semiconductor industry. Thank you to Mr. Huang. And what's your opinion about this issue? I would like to ask President Ji Yuanliu.
Thank you. I think at this moment, the Taiwan status of the semiconductor industry is on the top. It's everything very good. So just like a flying wheel is rolling full speed without any external disturbance or something try to stop. I think we are going, no problem. Okay, so at this moment, what we most worry about is there is any real physics barrier over there. Then we'll stop there. All the follower will push up. So at this moment, recently, we read in the news, the NVIDIA CEO, Jason Huang, said, Moore's law is dead. But another one, CEO say, in Intel, say, no. Moore's law is alive and well. Okay, which one is right? I think either one is partially right. They're talking about this from different point of view. So if conventional Moore's law, certainly people say slowing down, and every generation get unproportional expensive. So people say Moore's law is going to die. But actually, we, scientists and the engineer, is very smart. Actually, Moore's law is effectively continual and pray. Okay, like my expertise, the memory, NAND memory. Okay? You cannot shrink in 2 dimensions. You stack on 3 dimensions. Okay? And it's continuous following Moore's law. Nothing wrong. Moore's law, still 18 months, the cost stopped by a half. Okay, cut by half. So effectively, there are many ways to do that. Okay, chiplet, whatever. Okay, I think effectively Moore's law. From my point of view, I will see it can continue another 15 years, no problem. Effective Moore's law. Okay, so for Taiwan, the most important right now is we want the government to support us with the people. Education most important, just as Mr. Huang said, people, okay? We need the electricity. We need the water, okay? If government provide this, everything will go, no problem. So I didn't see any problem. But if no electricity, no water, okay, no people, we just stop here. Okay, so the company will make all their effort. And if the infrastructure and the ecosystem exist, we like, as I said, flying whale. We are already at a full speed. Almost cannot stop. Otherwise, it just spin off, go to the other place of the world. So if Taiwan will maintain, so please provide, as I said. That's my opinion. Thank you.
Thanks to Mr. Liu's opinion. And I would like to ask Professor Ji Wu, what's your opinion? Not Ji Wu, sorry. Dean Jackson, sorry.
Yeah, I would like to thank Minister Wu and the organizer for the invitation, and glad to be here with all the experts. As Mike Campbell said it well, Taiwan will continue to be the most trusted partner of the world semiconductor and information industry. That's going to be 13 trillion in a little over 10 years. Now, I would like to add, since I represent the new Industry Academia Innovation School, in terms of what Taiwan needs to go from past success to the future success. You all know, if you buy stock, the past performance doesn't guarantee future performance. So the whole, not only the industry, the companies, they are already playing in the major league. They are on the, and the universities here, as one example, has been constrained by all those, especially national universities, all the regulations and so forth. So the government actually, with the new legislature, are trying to remove some of those barriers, allowing right now, I think it's like 5 or 6 schools setting up new semiconductor colleges. And the goal is, this is a new private-public partnership. And the model is a two-way, co-collaboration, co-creation kind of a model. We not only need, the companies needs to get breakthrough new technologies from Taiwan or from all over the world. And you need the talents to be able to put them together, to integrate them, to know what's good, what works, what may not work. And that has been Taiwan's strength in terms of not only the supply chain, but also in terms of like the foundry companies, the fabless chip companies. They are doing the platform business. They are providing very innovative, integrated solutions so that whoever in the world has good product ideas, application ideas, can leverage Taiwan's industry and the capability. So the university needs to go up another level. I don't mean they didn't do well in the past. It's just we need to go to a different level. So there are new, more changes and more innovations in how we train the engineers and so. But even that is not quite enough. In any case, government, as Chairman Lu said, needs to be the facilitator, need to be the partner of the private industry, the semiconductor industry, needs to loosen up more some of the regulations and provide all the what Michael Porter at the factors, the infrastructures, the education, all those, so that you can unleash the innovation power of the people here, of the people in the world. Semiconductor industry in the core of all the applications, all the industry in now and in the future, really is synonymous with innovation. So by freeing up, all these capabilities, these talents, training them, I think we have a bright future ahead. Thank you.
Thanks to Mr. Sun. Thanks. And thanks to Professor Wu being online with us. Thanks. And I would like to ask Professor Wu, what's your opinion?
So I think there are two most important things, and I think some other speaker probably already mentioned. And the first one is R&D. I think before we are not in the leading position in semiconductor industry, so we can just look at what IBM and what Intel are doing, and we develop the similar technology. And now we are the leading of the semiconductor in the world. So we have to spend more effort on R&D and to develop and to do the research and to find out what's the future technology. So that need a lot of investment. So I think STC and the Ministry of Education, I think they will invest a lot of funding, research funding in the semiconductor area. So R&D spending and the collaboration between the university and the industry become more important. So I think there are a lot of programs like TSMC have collaboration with a lot of national university in Taiwan, and that's a good thing. And I hope we can continue such collaboration in the future. And the second is the talent. I think the talent cultivation in the future is more important because now we have a lot of good engineers, but in the future we need more excellent and great engineer. So, but our engineer now mainly came from the university, and we probably need some foreign students to kind of adding to this pool so we can have more engineer. And another area is the female engineer. If you look at the semiconductor company in Taiwan now, probably the ratio of the female and male, the female engineer, the ratio is still low. And that's the area we can put focus on, because if we have a more female engineer to kind of participate or join the semiconductor industry, I think our talent should be enough. And I think for a lot of female students, because I'm a professor too, so a lot of female students, their presentation skill sometimes better than the male student, and they doing things more carefully. So we should encourage more female students to kind of take the engineer course or take the engineer degree and go into this industry. I think this is in the future, that's something we should do. Thank you.
Thanks to Professor Wu. Thanks. Great point. Female engineers, yes. Okay, and please stay on the line because we'd like to discuss about the talent issue deeply. The Department of Electrical Engineering of National Taiwan University has nurtured many talents in their past. However, semiconductor industry in Taiwan and around the world today are facing a serious shortage of talent, as you mentioned before, especially when Taiwan's semiconductor industry has reached a top position in the world. It has a greater demand for high-level R&D talent. So, Professor Wu, can you share with us what Taiwan universities should do in order to help industrial creating competitiveness in the next decade?
Yes. So I think the Ministry of Education, they create several semiconductor college in the past year. And I think like National Taiwan University, National Jiao Tong University, Tsinghua University, and the Cheng Kung University, we all have a good semiconductor engineer now in those national university. And now we can develop more research program. And as I mentioned, we still, because if I look at the student coming in last year, most of them are still male students. And as I mentioned, that's the female student in some area. We might need to go to the senior high school and to kind of, promote engineering education. And in our research, we need to have a more practical research and connected with the university. And as the previous speaker just said, we cannot just do science for the semiconductor. We need engineer. So we need to in order to have a good engineer type of R&D, we need to collaborate with the industry. Otherwise, we're just doing the research along with the university professor. So I think it is great to have a more program on those programs which we can connect the industry and the university together, and we do the collaboration together and try to solve the future semiconductor problem and to enable the Moore's law to keep continuing for another 10, 20 years. Thank you.
Thanks to Mr. Wu. Thanks. And then next, we're going to discuss more about the Moore's law. Yeah, I'd like to ask Dean Jackson. We know that Dean Jackson was the former Chief Technology Officer and the R&D Vice President of TSMC, and is now the Dean of the Industry Academia Innovation School, National Yangming Jiaoda University. As Mr. Lu mentioned before, Mr. Jensen Huang from NVIDIA said that Moore's law is dead because even though cheap technology can still improve, but the price is becoming more expensive. So I'm curious about that. Dean Sun, can you share with us your view on Moore's law? Do you think Moore's law is dead? And how can we overcome the challenge about increasing the investment cost of advanced technologies and technological barriers?
Yes, thank you. Yeah, I think there has been always this debate or the prophets saying that Moore's law is dead, depending on which side you are on. And but as we all said, and you heard, keynote speakers and or the panelists, really, we are into the era of what I would call the 3D times 3D, okay? The super Moore's law era, which I mean is, as you've seen on the slide from Mike Campbell, that there's so many possibilities to integrate different kinds of chiplets together, and that goes hand in hand with advances on the planar, on the monolithic, what we call. You build one layer at a time, build on top for the 3D CMOS scaling, right? And the transistor is no longer planar; it's already going 3D. So even without new materials, we can already get more equivalent density of transistors on the chip. It's just one example. And there are new materials that's, it may take 10 more years or for some of them to work out all the sort of technical challenges. But personally, I'm optimistic that right now with these FinFET extensions, these nanosheet, these gate-all-around structures, it will buy us some time in terms of getting some innovation breakthroughs in the new materials. So we can sort of get around some of the physics limitations along the way. Just like immersion lithography, which bought us time, bought us like 10 years before EUV is ready, right? And we remove one of the hurdles in terms of dimensional scaling. So really, it takes good science work in the academia, but science cross-disciplinary training for the students, like what we are trying to do, to bridge from the academia to the industry or the practical side. We have good engineers who can really see what is ready, what is good to be integrated, and to continue this empirical law in terms of doubling the density, on a footprint, on a small chip or on a small package, and every 18 to 24 months. So just like Chinese sayings, I've seen many times, 山穷水尽疑无路，柳暗花明又一村. When you go in deep in the mountain, you thought that's the end of the road, end of the world, but after a turn, with innovation, there's another world opening up. Yeah, that's my comment.
Anyone want to add? Okay, Mr. Lu.
Okay, I have a slide I can show you.
Slide?
You see that? That's my slide. I showed this in 2 years before in VLSI TSA invited speech. As you see that 3 guys, they stand there. They take the step of scaling FinFET 3D memory and up to there. And he is also talking about all the photonics, 3rd generation semiconductor, chiplet, heterogeneous integration. All these things is on the roadmap already. That means we know how to reach there. You just need effort. So the roadmap is put there. We know how to do it. Just depends on how much effort you put and which country, which one is reach first. And reach for what? You see, you stand on the mountain. You see under there, IoT, AI, artificial intelligence, 5G, 6G, and the power management, all those things. So with the technology you're in your hand, these good things you can harvest. So you see the gold, a lot of gold there. You go there, you get the gold. But you see something there? There is a cloud. These things are really disruptive. There is a metaverse and a quantum computing. This is a totally new game, okay? Different thing. So other than that, we have a roadmap. We know how to reach. Okay, those things too are totally disruptive. But 1 week ago today, Nobel Prize announced that this year's physics prize give to what? Give to 3 guys. They prove the quantum computing essential factor, entanglement of the quantum state, is real. So this is a formal recognition from the Nobel Committee at least, say this question, Einstein is wrong. What's wrong? Okay? Quantum state of quantum entanglement really exists. What do I mean by that? That means by quantum computing and quantum communication is possible. It's already from a philosophical argument down to science, real, proved test. So what next leave to us? We engineer and the industry need to pick up this something that's feasible to realize this so-called quantum computing. This is a totally different animal. Versus all these things as a science, technology, we all know. We also know how to achieve, just need our effort. So if we're talking about this, how you will say today, people? Frankly, I am an enthusiastic optimist of quantum computing. But today's atmosphere is a little bit too high, and full of cheating group, cheating money, using this terminology, okay? But we will say good things, yes, because this is possible. 2 months before, United States, NIST, National Institute of Standard and Technology, NIST, announced they already chose 4 algorithms to be so-called post-quantum cryptography. This is 4 candidates. What they are doing? US NIST, in 10 years ago, already started this program. Say someday, if really the quantum computer has come, people are exciting about what? All our security, everything is a break. And our keynote speaker, the last one, keynote speaker, talk about the security is nothing. It's totally wiped out by this quantum computing. If this happens, the industry is in chaos, right? So we need to prepare. So the US NIST already prepared, have 4 algorithms put in there as their new standard for security. That is another thing saying quantum computing will come, but don't know when will come. And I say right now is people are too hyped. But there are several barriers. It's totally unknown how to solve. First, the quantum device is not chosen at all. Now there are 10 more than 10 choice. We don't know which one is the final choice. Just like a semiconductor. There are more than 10 devices, bipolar, NMOS, CMOS. Which one is the one? Finally, CMOS pick up the winner, right? Now, we don't know this. So fundamentally, we don't know which device is the device. Second, we don't know how to interconnect. Like the VLSI Jackson built in TSMC at all. Totally don't know how to interconnect them out. That's totally a mess right now. Third, the error correction. There are too many errors. You almost need 10,000 bits to protect 1 bit. People talking about, I can build 100 bits. This is totally error bit. No use at the moment. So how to build an algorithm to error protection? So these things are all very tough engineering technology. So there is a lot of things people can do. So the young people join our industry. don't worry about lost your job. There are too many things, too many challenges you can choose. Okay? However, I said, there are people like venture capital get so much money nowadays. But turn out all the companies are negative. None of it making money at all. But their valuation is like huge. Some people say these are all cheating group. Okay, all the money they receive produce nothing. $0, negative dollar. But I view this as a necessary road we go to there. So many physics nowadays working on this receive maybe 10 times salary than as a professor in university. Okay, give to them to do the effort. Okay, so they spend the money. So the investor, smart investors don't care because if the evaluation is going up, anytime he go out, still make money, not lose money. But the last rat will lose money, okay, lose everything. But the social resources put in due to this hype. So I will say this is, I don't know how to say it. It's harmful or not harmful. Okay, I don't know. But this is an exciting era. So I view very young people here. You can try to devote here. Okay.
Thanks to Mr. Lu. Wow, so exciting. We have already turned into a new era. And next questions, I would like to keep asking Mr. Lu about the new technology trend. We know that Mr. Lu is Taiwan's Mr. Memory and used to host E3 submicron project and was a former president of Vanguard International Semiconductor. Today, Micronic is also a leading company in flash. Your spirit of constantly exploring new technology trend is so admirable. And Mr. Lu, can you share with us how new technologies such as quantum technology you mentioned before, and AI and third generation semiconductors will impact the industry, and how can Taiwan react to the opportunities and the challenges of these new technologies?
Okay, up to this question, my daily life, okay, what I operate is on a very advanced memory. Although very advanced, it's nothing to do with the quantum computing at all at this moment. And even for quantum things, how to do quantum memory now is zero. People don't know how to do it. We're talking about quantum, is quantum communication, quantum computing, but not quantum memory, because quantum's lifetime is too fast, so cannot to fulfill that. But for us to do the memory, we also just like an NIST, we are just put on our mind. If those kind of processor happen, if the communication comes, what kind of memory they need, okay? We can, at this moment, do this job to fulfill the new era. As I said, the NIST's algorithm is totally targeted with the quantum. Quantum can break the so-called RSA, security algorithm. However, there are many other mathematical methods can be installed, and the quantum is no effect to them. So you can be still safe, no problem. However, to distribute the standard all over the bank and the institute of the world, according to our past experience, need a decade. Need 10 years to do the distribution. So you need to prepare 10 years before that moment happened. So at this moment, we already need to prepare. When it will be coming, we don't know. Although at this moment, it most likely not happen tomorrow. So we still have a little bit time to do.
Thanks to Mr. Liu. Next, I would like to discuss about the new application. We know that Taiwan has established a solid foundation in the semiconductor hardware industry. Taiwan's semiconductor industry has reached to a top position. However, in terms of applications, it requires closer connection and cooperation with major industries around the world. How will NSTC assist Taiwan industries, especially keep up R&D momentum in order to maintain competitiveness in new applications for the next decade? I would like to ask Mr. Lee.
Okay. Because semiconductor is the core for intelligent innovations, it is reasonable to expect that Taiwan will move toward a smart society. Artificial intelligence, big data, the Internet of Things will be applied across people's life, work, learning, and almost everything. And the semiconductor is the core technology of all these aforementioned technologies. Because the wide application of the semiconductor, we National Science and Technology Council, the NSTC, has launched several major programs to further improve and spill over our advantage in semiconductor to other areas, including the 5 following major programs. The first one is innovative medical materials, accurate diagnosis and treatment program. Taiwan has the world's most complete supply chain in semiconductor industry. Many highly competitive ICT manufacturers and the sound medical service with abundant top-notch clinical medical talents. With these advantages, we believe that Taiwan has the potential for digital medicine. The second major program is the CubeSat Key Technology R&D program. This program focuses on CubeSat constellation communication, CubeSat propulsion system technology, telemetry technology, and scientific experiments, which involve microwave, optical, and laser communication, attitude control, ground reception, optical radar and camera, and the other technologies. The third major program is the key emerging chips for high-performance computing and for next generation communication. In this program, we have 3 major tracks. The first track is to develop the high-performance computing technology, for example, in the AI applications. The second track is to develop the communication IC, especially for 6G communication and sub-terahertz wideband communication IC. The third track is to further improve the EDA and the IC design environment. In particular, the TSRI, Taiwan Semiconductor Research Institute, will help to develop the design environment for the academia. The fourth major program is the next generation compound semiconductor. In this program, we would like to develop the high voltage component for the electric vehicles. The second target is to develop the high frequency component for the next generation communication. For the high voltage applications, we will focus on gallium nitride and the silicon carbon. For the high frequency applications, we will focus on gallium nitride and the indium phosphide. In addition, we will look into the new materials, for example, the diamond and the gallium oxide. The last one, the fifth major program is the quantum technology program. In early October, just about last week, the Nobel Prize in Physics was awarded to 3 scholars for their fundamental contribution to quantum technology, as we have discussed a lot today. In this program, we will further develop, for example, the low temperature silicon-based technology, quantum bit circuit design, quantum computer subsystem integration, and the peripheral related circuit environment. All of this will require solid and strong semiconductor technology. All the programs I just mentioned about are the key items on our NSTC funding agenda. We hope that Taiwan edge in chip design and the manufacturing will spill over to other industries. Thank you.
Thanks to Mr. Lee. And the last question, I would like to ask Vice President Yee Huan, which this question is really important. Realtek is currently the 8th largest IC design house in the world, with strong establishment in industries such as network communication, multimedia, and so on. And today, we see the electric and the self-driving vehicle industries are booming, but Taiwan has not established much in that market, and the supply chain is really different. So what's Realtek's strategy and plan, and how can Taiwan seize the huge business opportunities brought about by EV market?
Thank you. Sounds like I'm the one sitting between you and perhaps your dinner. So I'll be brief here. Okay. So you ask about automotive. You also mentioned Realtek has been quite successful in communication, consumer, this computing. Okay. So is it really a deviation from what we are doing? The answer is no. Actually, it's a natural migration. First, let me quickly say that all the good things we heard today about 5G vision, connecting everything, obviously, when everything is not connected, many of the things or all of the things we heard today wouldn't exist. My contention is no connectivity, no AI, no big data, no intelligence, no autonomous, no nothing. So the heart of everything is connectivity. So what does that have to do with a car? Why we even need a car? Okay, I think the pandemics have proved that we are not satisfied for being locked down in isolation. The moment we can move around, we will move around. And when you think about vehicle, cars, really vehicles is a better term. Okay, we need something to take us move around. And that something, what's happening there, I would like to quote Ford, European CEO of Ford Group, Executive Director, Mr. Herman. He said last year in Munich Auto Show, he said, my entry-level Ford Escort has 300 chips inside. My high-end electrical vehicle has 3,000 chips inside. What do you think all those chips doing in the car? Collecting information, they are computing. And do they all do that in isolation? No. All those components, they need to be connected. How do you connect them? Okay, so the idea start clicking by the automotive industry. They, before they can talk about this, connected car, they need to solve the problem first. In-vehicle connectivity. Once you do that, the doors start opening for all other opportunities. So my point here is the opportunities we find in vehicles actually is moving toward the direction of, I call it, moving to the direction of an IT platform. Now, the good news is that Taiwan industry, Taiwan companies, we are very familiar with how to compete in IT platform. As I said before, many of the Taiwan companies are viewed as non-threatening because we are not fighting the dominance of any platform. And car is moving to that direction. There will be platform-based vehicle. Just look at Tesla. Those who drive a Tesla, your car has over-the-air upgrade almost on a weekly, if not daily basis. So vehicle is becoming an IT platform. That's the opportunity for everyone in the IT industry in Taiwan. So, but don't take it for granted that with the success we have in IT, I will guarantee you any success in car. No guarantee, although that seems to be a familiar battlefield. What's the difference? At least I will tell you one major difference. Up to now, for example, when people talk about safety, security, these are two different concepts. Safety usually have to do with human life. Security usually has to do with data. Now, when people are sitting in a moving vehicle, your life depends on the moving vehicle. So the car safety will impact the person's safety. Likewise, the car data security will affect human safety. So the concept of security and safety are merging in the car. That is very important because that leads to the next concept. You have to have zero defect. Now, those who are not in the auto industry probably cannot really appreciate what do you mean by zero defect. Meaning that there's no chance to put a human life in danger. How do you achieve zero defect? Now, I will look at that as an engineering term, okay? So to put it simple, those who are working in the IT industry, look at quality as a concept I call quality by testing. Okay, you test the product you build. Those defects, you keep it in-house. Good parts, you ship it out. Those from the outside world, they look at your product after testing, they say, good quality. For auto industry, that's not quality. So the quality concept need to be changed. It's quality by design. So every phase of the design, you ask the question, how can my design fail? How can my circuit possibly can go wrong? what is my solution? So simply put, even quality by design, still that's the entry, that's the starter. Eventually, you need to go to quality by habit. Quality is a habit. If you don't have this concept, it will be very difficult for you to become successful in the automotive industry. Realtek have gone through that, transforming ourselves from an IT-centric design mindset, design by test, to design by quality. And that's the experience we would like to share with everyone. Car will become a familiar battlefield for the industry, but it cannot be taken for granted. And quality, safety, security, these are the important concepts you need to manage. Thank you.
Thanks to Mr. Huan. Thanks. Thanks to all speakers sharing your views on these issues. And as we discussed today, Taiwan's semiconductor industry is facing lots of challenges, but there are still plenty of opportunities waiting for us. Now it seems like the worst of the time, but maybe it's the best of the time. We need to work together to build the next golden decade. Thanks to all speakers again. Please give them a round of applause.
Okay, thank you, our moderator and our panelists. Thank you so much. And also, I would like to thank all of you to join the 2022 Food Text today. And at the very end, please scan the QR code on the screen. And please, you may return to the seat. Thank you so much for our panelists and our moderator. And right now, for our audience, please scan the QR code.